Hi, everyone. This is Brad Berwald. Welcome to our presentation today on remote data monitoring featuring Connexa's Noi and Morningstar's EMC1. We're going to be talking a little bit about remote site monitoring and a lot of the ways that you can tackle that. And we're pleased to be presenting with Michael Postel, the president of Connexa. And the reason we're doing this partnership is because many of Morningstar's controllers are deeply integrated into Connexa systems, and in many cases, not just on the power side of things for charging from solar, but also on the data connectivity side, as they've been introducing some new and innovative products that make that even easier, and more secure, and more capable. So that'll be the focus of our presentation today. Thank you for joining. A few housekeeping items. We are going to record this presentation, so like many presentations from Morningstar, you will find them soon after. If you're an attendee who missed it, through the GoToWebinar platform, as well as it will be posted on Morningstar's YouTube channel as well for later viewing at your own leisure. Also, the presentation is in PDF format attached to the handout section of the webinar platform. So if you are logged in, please feel free to download that and view it offline as well. And feel free to submit any questions throughout the webinar. We will likely address them at the end because we may get a chance to answer some of them, and then we'll wait till the end, and then Mike and I will work together to cover those in detail for you. Okay, so please submit any questions that you feel are of interest. Try to stump us. I do a lot of networking work. This is a data session, so feel free to ask us some tough ones, and we'll do our best. And of course, if we don't, we will get back to you afterwards as well with your email. Okay, so with that being said, thanks very much, and we'll go ahead and begin. Mike, if you could advance to the next slide. Again, Mike Postel is the president of Connexa, and they have been a longtime system integrator focusing very specifically on industrial off-grid solutions with high degree of specialization in security, oil and gas, telecommunications, and you'll see, of course, many examples of their products and power systems throughout this presentation. My name is Brad Berwald. I'm the Senior Product Manager at Morningstar. I've been with the company for 21 years and worked in a variety of roles in sales and marketing and product management. And I'm always pleased to do these webinars, especially when it's a great topic with a great partner. So the two of us will be guiding you through today. So thanks very much for joining us. Next slide, Mike. So a little bit about Morningstar. We are the off-grid experts, having actually just literally at the beginning of April celebrated our 30th anniversary. Over this time, we have over 4 million products sold since our inception in 1993 and worked in over 100 countries. And we apply off-grid systems to these mission-critical applications all over the world, anywhere from the North Sea to the Sahara Desert, McMurdo Station, all kinds of applications, you name it. And they've been proven year after year in the most extreme environments around the globe. And we also push for not only that breadth of market coverage, but also the highest reliability, because really the only one who can really kind of share that and has the timeline and the analysis of our product's reliability is that we've got the 99.9% success rate for hardware in the industry, along with our very extended warranty. Okay, and next slide. Morningstar is, we are in several locations. We have, of course, off-grid technical sales account managers around the world. We have our commercial office in Newtown, Pennsylvania. That's where I'm based. That's just north of Philadelphia. And our engineering office, where we have R&D, Q&A, some equipment assembly, testing, our extensive field of arrays. That is all in Jessup, Maryland, close to the DC area. Our products are warehoused in 2 very large primary locations in Los Angeles and also in Kaohsiung, Taiwan. And then, as I said, we have other salespeople throughout the world that we work with our customers to solve all of their problems and supply needs. Recently, you've probably seen a lot of activity from Morningstar because we've been participating in what I call the March rush for the beginning of the year, when a lot of the trade shows start really picking up, many going on in small telecommunications, security, of course, Intersolar North America, and others that are focused on energy storage, and some even with a specific application such as oil and gas. So if you see us around at those shows, please say hello, and of course stay tuned to our social pages, especially LinkedIn, to see some of the activities we've been doing at these shows. Okay, so next slide. So the topic of the presentation really is about connectivity, about connecting to devices. Obviously, a lot of internet-enabled devices or IoT-enabled products are, prominent in all markets, consumer and industrial. And of course, with off-grid solar, it's even more important that that capability is imbued in the system, because you've got a site that is typically powering something extremely important. It's often difficult to reach. It's off-grid for a reason, which usually means it's not exactly down the street. Mountain tops are not uncommon, and for that connectivity to enable the ability to monitor that site and prevent a truck roll or even a helicopter, it's incredibly valuable. So getting that data, making sure that the system is up and running, is really key. So when we have these types of systems connected, you'll notice that a lot of Morningstar's products have Ethernet on board, or they have our serial connection. And we're seeing more and more Ethernet. And with the serial connections, and one of the topics today with the Connexa Noi is that you can use that serial connection to connect to other devices that add even greater capability and monitoring functions. And Mike will be talking about that very shortly. So, but when we talk about what our Ethernet capabilities do at the site, a lot of times it is focused on enabling that local network to talk to other devices. Okay, so these would be standard industry protocols. We use MODBUS, which is extremely valued to the oil and gas industry. It's the technology of choice for SCADA systems. It is a system that is also largely makes up the SunSpec communications for even industrial and utility grid tie inverters. It's just very fast, very reliable, and very well suited to industrial environments. SNMP is Simple Network Management Protocol, and that is, you could say, very similar to Modbus, but with a specific focus on the telecommunications industry, because they're managing networking equipment, wireless connections. They want to measure bandwidth, see how their data is doing, because that's probably the primary service they offer to the market, as well as see the status of the energy system. And more, especially internationally, we've been focused on the greening and the off-gridding of cellular towers as connectivity needs increase. And then lastly, through these ports, we can also provide HTTP, which is your simple web dashboard. This is a local dashboard from the controller itself or other device that just gives a simple update. So that functionality is there, the connectivity is there. It's usually used a lot on site in order to talk with existing products. It's really valued by OEMs that are building around our controllers, system integrators that want to take control of the charging, manage the battery systems, as well as other aspects of the device will utilize these protocols and that Ethernet connectivity. The equipment is actually pulled, meaning it's the requests for the data are made to the device, and then it responds. You can even actually, in the case of like some batteries or inverters or rectifier systems, take control of the charging, and the inverter will, the charge controller will be managed by the customer's equipment directly. So they take over kind of the 4-stage charging process. So all this occurs securely because it's inside the local network. It's the same as in your home. It's not necessarily touching the internet. It's your lights and your home automation. Everything is happening inside of your router, inside the firewall, and behind the internet connection, and not on the public internet. And that's often signified by the infamous 192.168 IP address. So with this connectivity, there's a lot of power, and a lot of these other devices that talk to our products do also talk to the internet. But for our products typically to talk directly to the internet, it's a little more challenging, because when you go out onto a wide area network, things take on a little bit of a different role. To connect to that site, you typically are required to use a static IP internet address. You may have to use dynamic DNS. There are other options to connect to the site that some of our more security-focused industries do follow. They may use a virtual private network to connect securely. Port forwarding can can be enabled, but sometimes a little bit difficult to manage and not quite as secure as other applications. And then you also see some of these large virtual network providers, AWS, Azure, Google's cloud products as well. Their cloud platform can provide these virtual networks to be built as well. And that can add additional security beyond our charge controller to kind of augment it. But with these devices, Modbus, SNMP, they are kind of open protocols, and they are exactly what they are, an open protocol. They are not wrapped in any kind of an inherent security or encapsulation that would allow them to become encrypted. Okay, we rely on the network for that. Okay, next slide, Mike. So with that local connectivity, there's a lot you can do, and you are going to see these ports and Ethernet functionality on more and more of our products going forward. And the important thing is that the EMC1 is a product that enables that, and I'll be talking about that here on the next slide. In the case of remote IP monitoring, cloud connectivity is something that a Connexa device like the Noi can enable for you, and Mike's going to go into detail on how that is enabled and how that is set up and many of the benefits. And when this data is, instead of being pulled by an external device, it's proactively pushed out to the cloud. Okay, so this would be to those same platforms. It uses entirely different protocols from Modbus or SNMP, which are relatively simple. These are more elaborate, secure protocols like CoAP, HTTPS, or MQTT. And this outbound traffic goes through and beyond the firewall out onto the public internet, making it a little different from the protocols that are standard in our products. And this secure transport is really, you know, when you're out on the internet, the open internet, you need this security in place. So these products like Noi can take our devices and communicate that with them via serial or Ethernet IP, and then add on a lot of additional information, site management. Many controllers can be viewed together, you know, and this very easy hands-off configuration to get it to the internet is really the basis of what IoT enables for a lot of products. So next slide. So you can see in this diagram, our EMC1 is a Ethernet gateway product, and it is there to bring any of our existing products, legacy products, into the market. And this is something that Ethernet is standard on. The ProStar and SunSaver MPPT, of course, have that serial connectivity, and then any of the other products that do not have Ethernet functionality can actually get Ethernet connectivity with the EMC1. Next slide. And then a typical configuration, as you can see here on the screen, we've got, you know, your energy storage system, your solar array, your ProStar MPPT, and with the EMC1, that ProStar MPPT takes that simple Meterbus serial connection and gives it IP functionality. So now it has Modbus, it has SNMP, it has our live view web dashboard, where if you use any browser, you can connect directly to the ProStar MPPT's display and see incoming solar data, load current, battery state of health, data logging functionality, you know, all that is enabled. And then when you have connection to that switch or router, there are options to, you know, then access that system remotely as well. And this serves a variety of applications, you know, as I said, small telecom, oil and gas, lighting, and security all have, you know, big needs for these products. So we kind of give those open protocols, and then we let integrators sort of take that data and take things further by giving more of a system view, and they might also bring in other aspects of the system into the monitoring as well. Okay, and then with that, I will now hand off the presentation to Mike, and he's going to talk a little bit about Connexa's products, their many applications, and specifically the IoT functionality that he can then enable in our products with his Noi system. Okay, go ahead, Mike. Thank you.
Thank you, Brad. Yeah, hello, everyone. Just wanted to start off and say that we're really excited and proud to be a Morningstar partner with the data side of things. There's a lot of power that Morningstar has baked into their electronics that I think that a good amount of people don't know about or know how to access. So part of what we're doing here is trying to provide some extra value to make that easy. So we are a manufacturer and supplier of remote power products, primarily solar. We're based out of Comfort, Texas, which is very near San Antonio. We've been in this small solar world for about 15, 16 years and have been working with Morningstar products for the entire time. So proud to say that. Our solar power systems that we offer do range and voltage on the DC side from 12 up through the highest currently is 144 volt DC. And then we have 12240 up through 480 volt three-phase AC systems. On our structures and the mounting of our systems, we range anywhere from pole mount to ground mount. We build skids, trailers, and then specialty type of applications. For oil and gas, we do have a line of Class 1 Div 2 rated hazardous systems. So we offer that to those customers. On the component side, we do stock most of the components that make up these systems, anywhere from solar panels, brackets, enclosures, alternate charging supplies like wind turbines, battery chargers from AC sources, and structures, mounting brackets, etc. Our in-house capabilities do include a UL certified panel shop, or 508A and 698A. We do have a Comax Zeta for robotic wire processing, which is a world-class wire robot that feeds 36 wire barrels into the back of it, so our assemblies are very efficient. We have an in-house metals fabrication shop where we build our structures, which are skids, trailers, and racks. We have a large stocking warehouse in a couple areas, controlled inventory, and I wanted to also throw in, we do in-house development on the software side, and have been recently working with customers to do company-to-company integration. So we do write our own software for IoT and cloud, but we also write our own connectors, including company-to-company for, let's just say, Oracle, NetSuite, Slack, Google, or Asana. We do service a wide variety of industries, like Brad said, anywhere from telecom, oil and gas, security, all the way through building OEM products for other manufacturers. All right, so our data services here, get this. I want to start off with why we should even be talking about data. So the biggest is that it gives us the ability to do a lot of things remotely. So we can troubleshoot our systems remotely, get real-time alerts. A big thing is saving a field tech from going on site to find out why a site is down or to remotely troubleshoot it. There's a goal to remotely recover the site if we can, and we're going to show you some different ways we can enable that, as well as optimizing the system, analyzing the power data, which is stored both locally at the edge and in the cloud, predicting failures, limiting the downtime, as well as predictive maintenance. So why use Connexa's Noi? And our Noi is the piece of hardware that publishes, it's our IoT hardware that publishes data to the cloud, and it is bidirectional. But our value that we're providing is that it's a single source vendor for hardware connectivity, data, alerts, storage, and cloud service. So you have a single support contact if you need any help in any of those areas, as well as we try to make it very easy. Our firmware is based in the cloud, so when you plug the Noi into one of Morningstar's devices that can communicate, the Noi will know that you did that and pull the firmware for that particular controller down from the cloud. So it's all automatic. The MODBUS is done for you, and we have full online documentation to help you work through it. One second, guys, it seems to be a little stuck. There we go. So our hardware, we have our primary Noi device is our first generation Noi. It is a 4G cellular device. It does have some digital I/O on board. We triangulate the GPS, the location via cellular triangulation as part of the factory install of the Noi, but you can add an exact GPS position with an add-on. The cellular service is bundled with our IoT service fee on this device, so it's a low-cost annual fee that allows it all in one. It's all bundled up together. So one of the nice things about this one is that it does go into a very ultra low power draw sleep mode whenever low volt disconnect is activated. So whenever you have a site go into low volt disconnect, you can still communicate with the site to know that that is happening and know the state of things. And you could compare that with a weather forecast to maybe make a decision on whether or not you should send out a crew. So some tech specs on it, we are communicating RS-232 only on this guy. Like I said, a couple opto isolated outputs and inputs. We're 12 to 24 volt DC on the battery bank. And we have a couple other inputs for accessories. We have a very wide environmental range, up to 75C. And we designed this specifically to be in an enclosure in the Texas sun. So it's made to get pretty hot. And NEMA 3R enclosures primarily, so the humidity is pretty good as well. So our second generation Noi, which is coming soon, is a little bit different, and I'll show you a couple different topology examples of it, but it can be used as a primary wireless router or gateway. You could also use it with an existing router or gateway. It's nice because it has redundant SIM card options. The customer can now provide their own SIM card should they choose. There are upgrades for international use on this one, as well as IO and a lot of other accessories. We have the ability to increase the logging, which we'll go over in just a second. Well, the logging intervals are able to be increased drastically to the cloud, and we can do 232 and 485 with the new Noi. So here's an example of our existing Noi, the standard topology. So you'd have a solar power system with one of Morningstar's charge controllers, and depending on which one it is, you may have to use this Morningstar MSC. And so the Noi will actually communicate via a very low cost, but also low megabyte per month connection to a 4G LTE connection to for example, AT&T cellular. And if you have your primary communications as, let's just say, a cellular router, that would actually be separate. And one of the benefits of that is that if you lose primary communication on your site, you can still log into the power side and see what happened, as well as cycle the load on and off. But in this case, this is going in parallel with an existing wireless or other gateway. The second generation Noi will allow you to do the same, should you choose, but it does give you a couple more options. So option B for the second generation Noi is to not use the cellular portion and use it as an IoT, a local IoT device that would have an Ethernet connection to your cellular router or wireless gateway, and it would go in line from the charge controller. And so this particular arrangement has some pros and cons. One of the cons is that if you do have your primary gateway go down, the site will be dark, but it does save on a small monthly connection charge. Option C is that you can use the second generation Noi as your primary gateway. And like I said, it does have dual SIM, so you'll be able to achieve all of the speeds that you're used to, and you can plug the loads directly into it or via a switch. So it'd be an all-in-one, and that would save you a piece of hardware on the IoT side. So from the edge to the cloud, at the edge we have the power system and the electronics as well as a Noi, and we publish straight to the cloud via the cellular network, at least with this Noi, and we make that data available in 3 ways. So we have a front end that I'm going to demo for you here in just a second, and then we can also make it available with AWS and Google Cloud Platform. So for you that are running applications that you need the data on the back end, we can make that available natively. So our logging intervals right now, our 2-hour logs are on this list here. We do log daily, as well as have some baked in alerts that are factory. So you can browse through these lists. But I think that one of the really nice things to see is just how much data is available inside of one of Morningstar's charge controllers. So these are all the data points that you have access to, as well as these are the actions that you can take. So any data point in a Morningstar Modbus table, we give you access to via our cloud. And we also give you access to perform any of the actions that are available in their charge controller. And this list will be available in the PDF after the slideshow. So as far as our cloud, it is very easy. We tried to make the entire process very easy. So you go to Connexa Cloud and you sign up, you create an account, and then you simply add a device and you start to populate your fleet there. So once you're in, this is the top of the page where we have our cellular status. We'll know if it's online and the signal strength. We also have the ability to give you 3 different tags if you wanted to sort your fleet or have different regions or whatever works best for you. We left that pretty open. We have the charge controller model that's plugged into it, as well as the charge controller firmware and the system voltage. We give you the ability to toggle the load on and off. And as far as the wiring of the Noi goes, it will actually wire on the power side directly to the DC bus off the battery. It will bypass the load connection on the charge controller, because what we want to do is we want to keep the Noi alive and up whenever low volt disconnect activates. So we can pause alerts simply here, and due to customer request, we can go to a daytime only mode or a nighttime only mode. The nighttime only would be for solar lights or products like that, and daytime you might be taking pictures of a commercial construction site and you don't necessarily need to run it at night. So one example of that might be that you get an alert that your system is at low voltage, and then possibly at that time you look at the forecast, determine if the next couple of days are sun. You might just leave it, but let's say it's going to be cloudy, then you can come in here and restrict the load by going daytime only, and that would cut the load almost in half depending on the season. So our battery gauge, we are replicating the LED colors on the Morningstar controller here, so red, orange, and green. And then the action tab will allow you to perform any of the actions inside of the charge controller over the air. And that includes controller factory reset and different ones. So this is in the middle. This is going to be your historical data for solar battery and load. As a quick snapshot, you can change the interval very easily and get a picture of what your system is doing. This is a test system that we've been really running through, and we have a heat load on it, and we're testing batteries with it. So you can see there's a lot of variation. So our IO is mapped to the cloud. So if you do need any IO, it is available very easily, as well as the location, whether it's triangulated or exact, is right here. And then our alerts are listed. So any of the alerts that were sent out are in that list in order. And then on the data side here, this is where you could query any of those data points over the air. So most of that data is stored at the edge in the Modbus tables on the charge controller. And then you query it from this screen right here, and it will deliver it over the air. With the 2nd generation Noi, we may be able to store more in the cloud should a customer want. It's really about the data plan that's available. So we have full documentation online. It will tell you everywhere from how to set up the hardware, troubleshooting, working with the cloud, the different types of hardware that's required to connect to various controllers at Morningstar. And we tried to make it very easy and very intuitive. So that's available and ready. And the future of Noi is more integration with more Morningstar. So the GenStar, SureSign, and RD1, those will be rolling out very soon. The RD1 into the 2nd generation Noi already. We have slated to build API calls to the National Weather Service to bring forecasts into the platform, help us make decisions on alerts and so on. Having a REST API for developers and customers that need to access that for custom applications that do not want to use Google Cloud or AWS or just need a REST API. Machine learning predictions, definitely coming. Control networks, organizational permissions just for larger fleets, giving you more ability to customize with bigger and broader permission sets for users, as well as changing the data logging intervals. So if you wanted to store more in the cloud, you would have that as an option. So that's the quick 20-minute Noi cloud IoT presentation, but we're more than happy to take any questions, and hopefully it was not too much at you at the same time. Brad, are you on?
Yes, I am. Thanks very much, Mike.
Yes, sir.
Okay, very good. Yeah, so appreciate that, and really exciting to see. I know with wireless and IoT and a lot of these low-power devices, it looks like you're taking advantage of the changes in the industry as things keep moving. Getting smaller, faster, cheaper with the Noi 2 coming along very soon. So it's exciting to see some of those new capabilities. Yeah, so everyone, I hope that got you a lot of questions answered with the, both what you can do with the EMC1 as well as how far you can take things with the Noi for, total site management. So I do have some questions that are coming in. So please, if you have others, get them submitted and I will get them queued up for myself and for Mike. So Mike, not surprising, quite a few here for you already. So I'll give some to you here. The first question from Troy is, what is the cell service and the IoT service fee per year? So I guess they're looking for not only the wireless connectivity, but the activation fee for the Noi in terms of costs.
Sure, yeah, we currently have it set up and it bills through a credit card, so it's all automatic. There's not any manual processing required, so you do everything online. And it works out to about $16.25 a month right now with the current rate, which is $195 a year, I believe. And that includes the cellular service and the cloud and everything bundled.
Okay, so that's all connectivity plus the actual getting onto the network itself as well is bundled in.
Correct. That's going to be, yeah. So our current data usage is only about 3 megs a month, so it's very low.
Okay, good. Okay, thanks very much for that. Next question from Dan. I have a Noi and the Morningstar PWM charge controller, and I also have an MSC connector. What is the difference between what I have now with the Noi and the EMC1?
Yeah, so the Noi would not necessarily work in the same system as an EMC1 per se. What we're doing with the Noi is we're communicating and translating the MODBUS protocol, and we're going directly to our cloud with it, or the AWS or Google Cloud platform, publish and subscribe. Whereas the EMC1 would allow for you to access it on a TCP/IP network. You could reach out into the device using Modbus over TCP and SNMP. Is it SNMP? There you go, Brad. So it would be a device that would be not used together, or the devices wouldn't be used together. They'd be used separately.
Yeah, and if I could add to that, it depends on the connectivity. As I said, with the EMC1, it kind of gives you the opening to access those protocols, but the rest of the suite, the software, the device that's actually collecting the data itself still needs to be brought into the system, often done by third parties or an OEM, whereas when I see the presentation with Noi, it's a complete package, data collection, transport, as well as the actual cloud portal itself to log in and view that data. So it's a little more end-to-end, I guess I would say, depending on what your goals are. Okay, next question. Will I ever be able to read and record the input voltage to the charge controller from the PV? I want to keep track to see if I need to clean the panels. So I guess this would, in regards to your system then, Mike, would the Noi be able to collect things like VOC, VMP, those operating voltages of the array itself?
Yes, and so my colleague Kobe is on, and we'll have Kobe answer that. But anything that Morningstar's storing, we are making available. So Brad, if you guys are storing it in the MODBUS tables, we do have access to it. But Kobe, would you mind commenting on that?
Yes, of course. So we are recording on a 2-hour interval with the current Noi iteration. So we only record 8 to 10 data points. So at a real high level, we are recording the input voltage from the solar array, which I believe would accomplish what you are trying to accomplish with knowing if the panels are dirty or not. But on the next generation Noi, you will actually be able to specify how frequently you want that data published and also exactly which data points that you want to record. So you could record every half hour if you wanted to, and you could record some of the more technical data points that exist maybe in like the EEPROM of the charge controller instead of just very basic high level, what is the array voltage?
And Kobe, to clarify, when you say record, you're meaning record in the cloud?
Yes, correct. I mean store in the cloud database.
Yeah, if I could add to this too, I think this is one of the advantages of when you've got that connectivity and when you can log data, a lot of data, and use the pretty much infinite storage of the cloud. You could go back, because dust and dirt accumulation won't occur in days or weeks, but it will occur in months and definitely years. Looking back at longer term, older data and seeing that my average peak power was, this, and then I find out that my average peak power today is, 10 to 15% less, that to me would be indicative of, module degradation or dirt, so I think those things can be realized. Okay, thanks for that. Will the next question, Mike, will the cell connection work in Africa?
On the current Noi, no, but on the next one, there is an international hardware option that we will be able to do that. But just due to the nature of, we have a lot of flexibility on what SIMs get put into it. So I think it's a soft yes. Kobe, do you know if it's for sure yes?
It should definitely work. The Gen 2 hardware will work in Africa. I'm sure we would just have to work with the customer to choose a cell network that provides good enough coverage.
Okay.
Very good. Yeah, it's nice with a lot of the cellular modems, they're really kind of all aligning themselves. Like it used to be different technologies, different networks were incompatible, but with LTE, I think so much of it's been brought together. It's becoming universal. So good. What are the planned methods for GenStar integration? Are you waiting for SNMP capability to roll out? So I guess future plans for the GenStar. I'm eager to hear an answer to this as well.
Yeah, it's definitely slated in our dev plans. Kobe, I'm not sure where it is on the priority list, but I know it's on there.
Yes. Right now we are trying to get the Gen 2 hardware to be on par with Gen 1, but then moving forward, all of our development efforts will be on the new hardware, and I think a big part of that will be working with the new generation of Morningstar hardware, including the GenStar.
Okay, great. Yeah, happy to assist you there. Just to add to that, the SNMP would be an additional capability that is coming in the near future with a firmware update, and that was a topic of this presentation. However, for Noi support, they're primarily using Modbus, which is standard and is the first enabled protocol in all of our products. So that is available now. Obviously, the Modbus table is even longer, and we do have that available now. So we will get together very soon and get that integration started for you between Morningstar and Connexa. Next question, I believe I can take this, and I want to make sure I'm answering it correctly. What percentage of the 30M is used by the Modbus overhead? So I guess I'm not sure, Jeff, if you're asking the percentage of the power, in other words, the self-consumption of our 30M product, the ProStar, what percentage of that is used for overhead for just the data transport? I would say, I don't know percentage offhand, but I know that the Modbus communications is there anyway because the product runs itself off that data. So accessing it through the data port is really a negligible energy draw. I mean, it's almost not even there. Let's see, Jeff, I had an additional question, one moment. The consumption of the 30M cell contract. Okay, so you're saying what portion of Modbus overhead does that actually take from the allowable cellular usage data? I think that's what you're saying. Yeah, so if you get 3 megs a month, you know, how much of that is usable data and how much of that is consumed purely in transport overhead? I think that's what I'm asking. And Kobe, I think you may be familiar with this because I think the Modbus overhead is not nearly that much. It's really I believe your IoT protocol and encryption that's adding overhead. So do you have any idea what percentage of overhead that is versus the data you're actually able to move?
Yes, of course. I'm not sure if I could answer exactly what the percentage overhead is, but as I mentioned earlier, we are logging every 2 hours. That number is kind of baked into the Gen 1 hardware at the moment. So if you go onto the Docs website, you can see for each charge controller model, all of the data points that we are uploading every 2 hours. And then that comes into around 3 megs. That's that 3 meg number that everyone's been throwing around. We also give the customer the ability to make requests on top of that. So at the end of the month, you will probably have used more than 3 megs, but that will be just the data that's logged in the database.
Okay, thanks for that, Kobe. Yeah, we've had a little experience too with some of these questions on overhead, and yeah, we found that what's really interesting too, and I know this looking at the protocols and the platform that Connexa has used, is that these IoT protocols, they're designed to be really light. They do not have a lot of bandwidth consumed by transport the way a lot of other internet protocols do. So it's definitely beneficial. And having the local storage capability also allows you to in some cases batch data together. My analogy is when you go to Home Depot, fill up the truck, use all the bed space, every time you make a trip, and then you get the most out of it. And that's something that's kind of a theme in industrial communications. Okay, next question. Real quick, when is the next generation Noi becoming available?
Kobe, I know you hate that question.
Yeah. That one I am not sure I can answer right now. It's sitting on my desk. I'm working on it every day, so we will get that as soon as possible, but I don't want to say anything that's going to get me in trouble right now, so I will keep that one to myself.
It's definitely a 2023 rollout, and if I can toss something out there, let's just say maybe late summer, early fall type of thing, but that's definitely not a commitment.
Okay, thanks. Yeah, always challenging. Well, at least you have the existing platform, and the next one's an even bigger upgrade that everyone can look forward to. Okay, next question. Are there plans to connect via satellite for data transfer?
So we can do that now, or I'm sorry, with the addition of the 2nd generation Noi, we will be able to do that finally. We weren't with the 1st generation Noi, And so on one of the topologies, you saw that you could essentially turn the Noi into just a local piece of hardware that's doing IoT and connecting to a gateway. So you would just Ethernet to the the satellite gateway. So yes, we could add that on generation 2.
Okay, very good. Let's see, a couple other questions here. We're getting some very good technical questions. That's a good sign for sure, in my view. Let's see, is the Gen 2 Noi based on the Digi IX10 router, or was that an example image?
No, it is, the hardware is Digi hardware, and so we will be on the firmware side of it.
Okay, gotcha.
Yeah.
Very good. Okay, I think, let's see, another question, definitely for Kobe. Do you force auto transmit on weak cell links? And is this cancelable?
So the current hardware has the capability to kind of bounce around between all of the available cell towers in the area. So I'm not sure if I'm understanding the question entirely, but we will connect to the tower that provides the best signal. If signal is not available at the moment, we also store some of the data locally. So if during one of those 2-hour log windows, the cell connection is down, we're not gonna try and publish data and just pray that it makes it to the cloud. We're actually going to store that data locally for some time and wait for the connection to come back up before pushing it through so that we can confirm that it makes it across. This data is very, very important to us. It's kind of what we're basing this entire platform around, obviously. So we do everything that we can to make sure that none of these data packages are fumbled in transit.
Okay, very good, thanks. And then last question was, just since we touched on is satellite connectivity an option? The follow-up question to that is, do you have any satellite providers in mind for that connectivity?
We do not have any partners, so I would say no to that question. We would be open to the provider.
Okay. Let's see. Okay, I think, let's see, one final question came in and then we will wrap things up. And by the way, all these questions, all the requests of the questions, emails and everything of the registrants is all there, and we will certainly follow up. I think there's a lot of good technical discussions and, some continued Q&A that we can take offline as well. So thanks for that. So one final question. Can the Noi format data to fit the packet specs of the Globalstar satellite network, which they also mentioned happens to be 9 bytes?
So I think that this is why on the first generation Noi we erred away from using satellite. Satellite connection seems to be better for emergency use cases where you only need to get 1 or 2 packets across, whereas we're kind of trying to hoard and stockpile data. So I think with Gen 2, it's definitely going to be up to the end user to restrict the amount of data that they are pushing across in order to fit within the really tight restraints for satellite. But we definitely try to compress the data as much as possible. So because that's what we're paying for. We want to keep all those costs down. So
Yeah, and we have not worked with satellite much or possibly at all. So I'm not sure, possibly the satellite gateway would actually create smaller packets for transmit. I'm not sure.
Okay. Yeah. All right. Well, thanks, guys. Yeah. One thing I get to that is, as I've followed cellular connectivity, you've got everything. Everyone always thinks the next technology is often better, faster, but there's many different types for different applications. Like you can't compare 5G to narrowband IoT. And I think with satellite, you can't compare Starlink to, a global star SOS beacon. They're just different services, but there are ones out there that will fit these industrial use cases and provide a good blend of reliability, bandwidth, and then of course cost. It's just a matter of choosing those and adapting the application to what you have to work with. So very exciting times for sure. Okay, well, that is all the questions. So thanks very much, everyone. And we will follow up on some of these offline. And I will share these, of course, as well with Connexa, with Mike and Kobe. So that concludes the presentation today. So thanks very much, everyone. And thanks to Mike for putting this together and presenting with me. Always a pleasure. I think whether we, are teaming up on these applications, our marketing events, shows, it's always time well spent with you. So appreciate that very much. And thanks everyone, and look forward to the next webinar here in just a few weeks in the future. Okay, take care.
Thank you.
All right, bye-bye.